My name is Kyle Escamilla, and I am the training coordinator for EandM. I'd like to thank you for attending our webinar today focused on compressed air preparation in pneumatics. After the webinar this morning, we'll be doing a short Q&A, so please type any questions or comments into the Q&A box or the chat, and we'll get to them at the end. Now, I'd like to introduce your speaker for this morning, uh, Caroline Hodes. Caroline is a product specialist here at EandM, so good morning, Caroline.
Morning, Kyle. Thank you. So as Kyle said, this is a webinar in compressed air preparation in pneumatics. With me, I'm joined by my colleague, John Hill, and we also have Chris from Festo on the line as well. So they'll be able to kind of help answer any questions in addition to any, or they'll be able to help answer any questions in addition to me. So I first wanted to go over what we're going to talk about in this presentation. So the first thing is to kind of explain how air preparation improves the process reliability, machine availability, and the service life of all components. Next, we're going to talk a little bit about the criteria for choosing the best service unit, and then what kind of physical principles will be needed or taken into account. Then next, we'll be going over the functional principles and areas of application for the different service units. And then finally, and what I think a lot of people are here for is kind of how to configure a service unit for optimum performance. So there are quite a few benefits to compressed air prep within a system. The main benefits being that compressed air provides speed, power, precision, and safe handling. And that really looks like that following graphic there, which is that you start with ambient air that then gets flows through a compressor and then through a reservoir and then through a refrigeration dryer and then through our air prep unit, which is what we're talking about today. And then finally, once that air goes through the air prep unit, then it can then be used on the machine. So why is compressed air prep so essential? If we were to use unprepared ambient air, there's quite a few different kinds of contaminants and things that would affect a pneumatic system. So the 3 or 4 kind of main contaminants that make up an unprepared ambient air would be those dirt particles, which could be up to 180 million between 0.01 micrometers and 100 micrometers. Those typical particle sizes are kind of listed below for viruses, tobacco smoke, water vapor, and hair, which are all some examples of dirt particles, but not necessarily all of them. And then also water. Water is almost always in all of our air supply, and it can be made up as humidity. And then oil can also make that up, and as well as chemical contaminants. Another really important thing to note is that when that ambient air is compressed, it means that the concentration of contaminants will increase when the volume of that ambient air decreases. So there are a list of direct and long-term consequences of contaminants. So for particles specifically, those particles can kind of create deposits in mechanical friction. And for example, that could look like particles that are get deposited between the cylinder wall and piston seal. And then there's water for contaminants, which can lead to the corrosion of parts, and that can generate rust. And then rust will cause mechanical damage or block small flow across sections. And finally, the last contaminant is oil, which can lead to particle clumping and can also block cross sections. And then oil can also cause elastomers in the seals to swell up. So the long-term consequences of that is that there's higher maintenance costs associated with it, as well as operating malfunctions and reduced service life, and lastly, higher energy costs due to those leakages. So there's three main features and things to consider when choosing the right service unit. The first one being air purity, the second one being airflow, and the third one being air pressure. So air purity will improve that service life and efficiency of the pneumatic system, and it will allow it to be used in accordance with those applicable regulations. Airflow is a specified travel speed that requires the correct flow rate, and then finally air pressure feeds into airflow, which provides the right amount of force to remove those required components. So air purity looks a little like something like this. This is an ISO uh, graph that Festo has created. So the standard purity class that Festo follows is 7.4.4, 7 being the class for solid particles, 4 being the class for water, and 4 being the class for oil. And then that's highlighted in the blue there on that slide. So going over a little bit more detail about airflow. Airflow is determined largely by the flow cross sections and the design. The greater dimensions of the service unit, the higher the flow rates, and the smaller the dimensions of the service unit, the smaller the flow rates. So some criteria that's really important to consider when thinking about airflow is thinking of whether or not those cross sections are too small. And then also, not only are those, if those cross sections are too small, but also if the disturbances are being caused by those long lines or branches or any additional laying radii that are too small. And then are there any raw surfaces on the insides of those lines, or if there's any contamination in there? And then lastly, are there any undiscovered leakages? When considering air pressure, there's an optimum operating pressure range needed. If that pressure is too low, then the efficiency can be compromised and it would prevent the system from functioning correctly. Then on the flip side, if the pressure is too high, there will be increase in the wear of seals or energy consumption and a noise element. Those pressure drops can be caused by consuming devices such as valves, filters, or drying units, but they can also be caused by long lines or branches and bending radii, similar to what we were talking about in that airflow slide. And then last thing to kind of consider is that 1 bar is approximately 1 megapascal, which is approximately 14.5 pounds per square inch. So here's the following list of service unit components. So the first one would be a manual or electric on or off valve, which you can have two. You can have either or both, as well as soft start valves, water separators, filters, pressure regulators, drying units, lubricators, and branching modules. And we'll be talking about all of these in the next couple of slides. But the main three that you would need at minimum are those three in bold, which is the manual or electric on-off valves, as well as filters and pressure regulators. So first going into those on-off valves, on-off valves do exactly kind of what they sound like, which is that they open and close the air supply that the system has. The valve will also exhaust as it closes and vent downstream pressure when it's turned off. And there are silencers available for on-off valves, which you can see at the bottom there on both of those pictures. The soft start valves will slowly build up pressure when a system starts. They'll only apply the full pressure until that certain point has been reached. Those downstream devices advance slowly to their initial positions to prevent material damage. There's two different types of soft start valves. The first one being pneumatic soft start valves, which will open fully as soon as 50% of that inlet pressure has been released. But then you can also, if you need more customizability, you can also use an electric soft start valve, which will switch to that full pressure at different points depending on that application. In addition to regular soft start valves, there are also safety options available for these as well as silencers. So there's two different types of water separators that can be applied to system. Water separators do also what they sound like, which is that they remove additional condensate from those compressed air lines. Those two water separators are the centrifugal separator, which will cause rotary motion that flows particles outward and then flows into the bowl. And then you have coalescence principle water separators, which means the opposite, which means that particles will flow from inside to the outside through a fine filter that must be replaced regularly. And then lastly, replaceable filters are available for those too. Going into filters, there are four kind of main filters that are offered. Filters are used to filter more particles, condensate, and oil in compressed air. And it really does depend on the application and what kind of particulates are present, and also what those requirements are for that compressed air. So coarse filters are filters that filter out particles between 5 and 40 micrometers. Those particles will flow through from the outside to the inside using the centrifugal separator principle. And then if you need to be a little bit more refined, there are fine and micro filters, which filter out particles smaller than 1 micrometer, and particles will flow through filters from the inside to the outside. Then there are activated carbon filters, which will bond that hydrocarbon residue, as well as odorants, flavorings, and oil vapors. And then lastly, there are sterile filters, which ensure that the air is sterile and free of any germs. One big thing to note about filters is that they do provide resistance and often limit the flow rate of a service unit. So it's really important to consider that specified flow range when picking out a filter. Next, we have pressure regulators, which control the operating pressure of the system and compensate for those pressure fluctuations. Pressure regulators can be used with a knob, which pushes the mainspring of the control piston down and allows that free flow. This is a really low cost alternative to a high flow upstream regulator. And another thing to note, especially with Festo's product line, is that filters and pressure regulators can be combined into one element of an air prep unit. Next, going into those drying units, there's three different types of drying units that are offered. Refrigeration dryers, membrane air dryers, and absorption dryers. So those refrigeration dryers are placed downstream of the compressor, and the air is cooled to just above freezing in a cooling unit, and then the condensate falls and is drained away. Then for membrane air dryers, these will lower the pressure of the dew point, and then the air will flow longitudinally through a bundle of parallel fibers. And the water vapor will diffuse and is drained due to the partial pressure drop. And then lastly, the absorption dryers are used when the dew points of -70 degrees Celsius are required. And those dryers use molecular forces to bond gas or vapor molecules to a drying agent. Talking a little bit about lubricators is that none of the Festo components require any lubrication. If any components are lubricated, it will require lubrication for the rest of its life or the rest of when it's used for. And then any excessive oiling can clog up silencers and other pneumatic elements. So lubricators really aren't recommended um, for Festo products. They also mention that the saying that oil it once and you'll be oiling it forevermore. So that's just another way of saying that lubricators aren't recommended. So next, going into the branching module, our branching module has more than 2 ports and can be used to or as an intermediate or end outlet for various air purities, as well as a support for auxiliary modules. Branching modules can also be ordered with or without a non-return valve, which could prevent the return flow of an oiled compressed air and any other substances. And then lastly, going into extended functions, there are a bunch of valuable functions that can be added into any air prep unit. So those consist of pressure sensors, differential pressure sensors, flow sensors, pressure gauges, condensate drains, safety valves, and energy efficiency modules. And a lot of these extended functions can be embedded into other air prep components that we just listed. So here's an example of a basic air prep unit with basic components on it. So on the right, you can see a graphic of a Festo configuration, and then on the left, I've labeled what these all mean. So that EM1 is a manual on-off valve with a silencer, and then the LFR is a filter regulator, and you can see that the filter regulator also has a pressure gauge on that as well. Then EE is an electric on or off valve on here. In this example, I didn't add a silencer, but a silencer could be added on the bottom of this. And then the DL is a start valve, a pneumatic start valve, which is right here. And then lastly, we have a branching module, which is the FRM. Then if I were to take any of these basic components, I could add them to a larger system, and this larger system could be used as a higher purity class. If there is a higher purity class requirement needed for that application. So in this example, we added the basic components in with a water separator, a fine filter, microfilter, and membrane air dryer, and an activated carbon filter. And also that membrane air dryer could also be replaced with an absorption dryer as well. Another thing to note is that pressure gauges and sensors can be configured individually for monitoring and displaying pressure and flow rates. So the final tips for compressed air prep. The first one would be to get your air preparation up to speed. It's a very worthwhile investment, and it is essential for a reliable production process. The air preparation will significantly improve the service life of your components and your system availability. any of those contaminants in the compressed air can lead to a lot of issues, including mechanical friction, corrosion, and clogging. Then, when choosing a service unit, always consider three factors. The first one being that air purity, as well as airflow and air pressure for your application. And then always make sure that your pressure dew point is 10K below your lowest ambient pressure, because this will keep your system free of condensate and reduce component corrosion. And then also remember that the air preparation involves a bunch of different stages. It also will cover a range of different modules for switching on, building up pressure, filtering, regulating, drying, and oiling. And there are a lot of different ways to use this depending on that application. Lastly, the final tip is in order to ensure optimum performance, make sure to arrange those components in your service unit according to the guidelines. So that was the end of our little webinar. The main source for this webinar was a Festo white paper titled Compressed Air Preparation in Pneumatics. And that white paper can be found using that QR code on the screen in front of you. If you also want us to just send it to you, we can also do that. If you have any further questions or anything, you can also email us at sales@eandm.com or give us a phone call.
Awesome. Thank you, Caroline. And we do have a bunch of specialists here in the call, so if anyone wants to raise their hand to ask a question live, we can hang out for a few minutes if you guys have any questions. There's also the chat as well, if you are looking for that. But I don't think I see many people with burning questions, so I think we can go ahead and close out. So thank you, Caroline, and thank you everyone who attended. If anyone would like to review any portion of this webinar, a recording will be available on YouTube and our website, eandm.com, once available, and you will also be receiving a copy of it via email. So I'd like to thank everyone for attending, and I'd like to wish you a great day.